All right, very good. Buongiorno, everybody, and welcome. Thank you for waking up so incredibly early in the morning on a Friday after a fantastic movie. How many of you guys saw the movie? Look at that. Was it good? I couldn't. My wife would have called the attorney if I would have gone without her. But also I had to finish the slides, of course. Welcome, my name is Vittorio Bertocci. I am a program manager in the identity team at Microsoft, where I look after our developer libraries. Today, I'm going to entertain you or bore you, depending on how you react to my accent, on how to take advantage of Azure Active Directory from your native applications, which means largely mobile clients. Come on, slides. Move forward. So, when you target native applications, you basically have two possible pivots. One pivot is the platform that you want to use. So, if you are a native iOS developer and you are targeting iOS, there is a kind of an obvious choice. You use Objective-C. And if the same goes for Android, Windows, and all the other platforms that you can target. However, that's not always a walk in the park if that's not your platform. And in fact, for explaining this thing to non-techies, I came out with this analogy, which is basically cuisine, national cuisine. Like if you come from a certain country, you know everything about your cuisine, you can appreciate the smallest nuances. But when you're visiting another country, you can feel adventurous, but it's not always easy to be open-minded. For example, a few months ago, I was in Beijing, and street vendors were trying to let me try this thing. And Italians are pretty close-minded when it comes to food, and it was kind of, I felt like when I sit in front of Xcode, and there is this Objective-C thing, in which all the methods have to end with the first parameter. Why? Can't you just wait when I give you a parameter? Why do I have to put it in there? It's just a matter, like, I'm not saying it's wrong, simply I'm not used to it. Luckily, in the modern times, there are also other options. You can pivot against the language. There are different ways in which you can take advantage of languages you already know, C#, JavaScript. And there are frameworks that allow you to use your favorite language and target the platform that you want. And that's kind of equivalent of wandering around and even if you are far away from home, finding a Burger King. Of course, I don't go to Burger King even here because I am Italian, so I'm sorry. But given that I expect that the majority of you guys are from the US, I try to craft a metaphor that works for you. How many of you guys are from the US? How many of you guys are from China? All right. I'm sorry, it looks great, but I couldn't try it. I ate the jellyfish, though. I ate the jellyfish and then shark fin soup. That was long ago. All right, now let me be slightly more serious. Clearly, when we talk about native apps, we are talking about those three big platforms. You have iOS, you have Android, and you have all the flavors of Windows, from a classic desktop on Windows 7 to Windows Store applications, to Windows Phone applications, to now Windows Universal applications in Windows 10. And the good news is that you can choose to live at the native level. You can choose to operate at the language level. During this talk, you'll see details of all these red boxes. For the time being, I can just tell you those red boxes help you to take advantage of Azure AD from your native apps. In fact, I even came out with a slogan that rhymes. Choose any platform of dev stack, Azure AD has your back. Isn't that memorable? And the way in which I'm going to structure this is as follows. First, I'm going to describe what is the high-level pattern you have to apply when you want to take advantage of identity from a native application. This pattern applies across the board, regardless of the platform you are using. It's more induced by the problem and by the protocols that we use. Then I'm going to explore what it means to take advantage of native stacks. And I'll go through all the various platforms. And then I'll discuss how to take advantage of Xamarin for C# and Cordova for JavaScript. Is it me, or suddenly I sound like the Pope? Why do I have an echo? Echo, echo, echo. Never mind. You are adding special effect that doesn't even public. I dig that. Now, this session is going to be mostly about the how, not about the why. I expect that you have been to many of the Office sessions in which you were sold about the fantastic value of our ecosystem, that you have been to the various introduction sections. I'm not going to redo an introduction, but just for reminding you why we are doing this, the opportunity when you take advantage of Azure Active Directory is really, really compelling. We have more than 5 million organizations using this thing. If you wanted to integrate with Office or Azure, tokens from Active Directory are the currency that you must use. Like, there is no way around it. You have to get a token from AAD. And this service, even like if you don't want to integrate with existing APIs, but you want to just protect your own assets, this service is like one of the most powerful things you can find on the planet. Every day, we do more than 1 billion authentications with many nines of availability. So even if you try to do this yourself with your own hardware, it's just difficult to achieve that. So this is why we are doing it. Then I will not touch this again through the rest of the presentation. Very good. So let's look at the pattern. And for this, we have to drop out. So here you have the classic configuration that you can expect to find in a scenario where you are using a native application. And specifically, what you have here is your device and a remote resource that you want to access. The idea is that in these mobile platforms, you have resources that are owned by the device, the hardware. So things like storage, things like encryption keys, things like access to your GPS positioning. And then there is a sandboxing system where applications live, so that you can safely download those apps from relatively untrusted places, like an app store, and then those apps can declare what they can do, and the sandboxing enforces that they can do only what you allowed them to do. So you never have direct access to the resources, like if for instead you have on Windows desktop. So what does it take to actually make calls to your system? Let me see exactly here. Okay, I have all of my stuff. Okay, normally, how does it work? Your application wants to have access to that resource. That resource expects your application to present something to prove that you have access. And that something is typically an access token. So there are a number of things that your application needs to perform. One thing is, for example, manage to pop out some kind of experience so that the user can enter their credentials, whatever those might be. This might be an access code, this might be username and password. Every platform will have different ways of doing this. So your application must be capable of popping this stuff out. And then once you have done that, you need to be able to craft a message for the place from where you are authenticating users. And in this case, my sponsor is Microsoft, so this place will be Azure Active Directory or Active Directory. But the principle is the same. If you are even working with a competitor, that's how things would work. And the idea is that once you gathered these credentials, you have to be able to perform a call. And this call has to conform to some kind of standard. Typically, every authority will expect you to authenticate using some authentication standard. Do you want to guess which standard we use in AAD for this scenario? It's early morning. I need you to be energetic. Go. Off. Thank you. You pronounce it so much better than me. Every time I say off, people look at me and say, ah? I said, off. Ah? And I work in identity. I say off something like 100 times a day, so that makes my life kind of miserable. But anyway, apart from these details. So you send this message, and if everything goes well, you get back what we call an access token. An access token is just an artifact that can be used for presenting to a resource and getting access. And that's the next step in here. You send this thing, and you grab a token, and you send it over. And now, normally, every good demo ends here, because I gave you satisfaction, done. Of course, reality is slightly different, because you will not just make one call and then go away. You will probably keep calling that resource, and you will keep needing that token. So that means that the token must live somewhere. So typically, you would want to have it saved in some kind of a session. And we'll see in a moment that things are even more complicated. Those tokens are short-lived. So just saving the token would not be enough. You'd be prompting for password in 1 hour, so bad. So this is the high-level idea of how you would want to operate. And what does that tell us? This tells us that in order to take advantage of remote resources protected by an authority, such as Active Directory, your application needs to contain some logic. It can be your application, or it can be the underlying platform. But somewhere on that device, you need the ability of prompting the user, crafting authentication messages, saving and managing tokens in a session. So you need those red thingies, which are used for representing this logic. Now, this is a high level. Now, let's go a bit further, and let's look at how you do it in Azure Active Directory. Azure Active Directory, again, I'm not going to do an introduction, but just to give you an idea, it's a multi-tenant system. Every organization can have a projection of their directory in the cloud, or they can have a cloud-only directory. This directory contains what directories normally contain: users, application, resources, and similar. And the idea is that you access it using endpoints which represent internet-ready protocols. So here I have a collection of endpoints. I'll keep it like this so it's big. I added SAML and AWS Federation for exhaustiveness. We do not use them in the mobile scenarios. In mobile scenarios, we use only auth, authorization endpoint, auth, token endpoint. How many of you guys are familiar with how auth operates? I'm not surprised. If you wouldn't, you would be still sleeping somewhere instead of coming to an identity session. If I wouldn't have to walk, I'm honest, talk, I would be sleeping right now. In fact, I don't know if you notice that I'm slurring, because normally at this time I'm like in REM phase. So if I start saying something odd, it's because I'm dreaming. So from this access endpoint, we can actually drive the experience that I described earlier. But here is an interesting difference. Instead of having your logic in your application to render the experience for gathering credentials, what we do is through our libraries, so you don't have to do it yourself. We offer libraries for doing so. We actually pop out a browser and navigate to auth authorization endpoint. This is an endpoint which, upon an authorization request, renders an authentication experience in the browser. So this experience can be as simple as a classic username and password, and can be as complex as username and password and various other multi-factor auth. Lately, my IT decided to make me miserable and make me use second factor auth everywhere I go. So 1 month ago, I was in Australia, and every time I tried to get my mail, I got a call from continental US saying, please give me your PIN. And the clients that I was using was always the same client. They didn't have to deploy any new bits to my machine because they used this trick. Instead of having the native client produce the UI, they pop out the browser, and the browser renders this UI. So the moment in which they added this extra capability, this just showed up. So it's very, very, very handy, because if there is one huge pain in the neck, is to redeploy client bits. So that's what happens. At this point, that's what happens. Now, another thing which is important to remember about how to do this with Azure Active Directory is that a directory will never give you a token unless it knows all the actors involved. It needs to know the resource that you want to have access to. It needs to know the client that is asking for it. Of course, it needs to know the user, otherwise authentication doesn't work. And it needs to know that that client wants access to those resources in advance. It's kind of, how to say, constrained, but for security purposes, that's what our architects decided works best. So you can imagine that inside Active Directory, you must have a little diorama, a little picture, which represents your solution. And that's the only way in which you can have a directory to spit things out. It's pretty easy. Like when you create your app, if you use Visual Studio, this happens automatically for you. Otherwise, you just go to the portal, and we'll see in a second. You enter a couple of coordinates, and you are provisioned. But you have to do this in advance. Once you have done this, and the user successfully authenticate, you actually get back from the token endpoint your tokens. And here, let's say that we are getting for the green resource, so we get these couple of tokens. Why do we get 2 of them? One of these tokens is the access token, the one that I described earlier. However, this access token expires in just 1 hour. So let me send it here. And so after 1 hour, what are you going to do? You can't pop another dialog. Well, Auth offers this great mechanism based on refresh tokens. Once I get this first access token, I also get what is called a refresh token. When I need a new access token, I can go back to my token endpoint and present my refresh token saying, hey, it's me again. I'd like to have a new refresh token, a new access token. And if the user is still a valid user, then the system will send me back another access token and a refresh token so that the validity slides. This is the way in which we give ourselves the opportunity to revoke those tokens. If I give you an access token that lasts forever, and then you leave the company or somebody steals your device, then we have a problem. Instead, in this way, the next time that the access token expires and you come back, if the user is no longer valid, we say, well, I'm sorry, no more tokens for you. So good. Now, in Azure AD, we have something that goes even beyond this. We actually have what we call multi-resource refresh tokens. Say that your application needs to talk to Exchange and to SharePoint, green and fuchsia. Instead of having to do, again, all the same dance when I have to talk to the new resource, here I can actually use the same refresh token to ask for a completely new set of tokens for SharePoint. So that at this point, from the user point of view, this just happened transparently, in the same way in which when you are on your own machine and you are using Windows on the internet, you just have access without knowing what's happening behind the scenes. This is actually something that happens only in Azure Active Directory. It's not specified in the standard. OK, that's pretty much the end of the theory. And given the time, you still look remarkably alive, which is great. Of course, you're doing emails as well, but that's perfectly fine. That's how it works. Very good. So theory gone. Now let's look in practice how to do this. And let's start with the native approach. Say that I decide that the best way of experiencing a platform is to eat its food. And so when I am on a platform, I want to use the thing that is native there. So we have a classic iOS, Android, and good old Windows, as we know. But in this build, we introduced a new platform, which is the Windows 10 platform, which does have its own way of dealing with this. Oops. Sorry, here I have to be a bit radical. I wanted to do this before starting, but the Ethernet didn't work, so I had to worry about making the Ethernet work. So pretend you didn't see anything, but we started from here. You didn't see anything. Those weren't the clip art you were looking for. Very good. So what happens is that given that we own Windows, instead of having to create libraries and to say, give you these libraries so that you can use them, but in the end, we are a guest just as much as you on other platforms. In Windows, we kind of like can move stuff around, and like if we want to dig a bunker there, we dig a bunker and we make it happen. And so that's what happened here. We decided that the ability of using these protocols was so important that it had to be plugged in the platform in itself. And so we created low-level APIs that are part of a system. You don't have to install anything. They are just part of Windows itself. And those things deal with all the tasks that I described earlier. literally at the OS level instead of putting it in the app level. And how does this work? In Windows 8, I don't know how many of you guys used it to sign in your machine using a Microsoft account, the artist formerly known as Live ID. How many of you guys? Look at that. OK, so you already experienced this fantastic embeddedness in which you enter your machine with those credentials, and then those credentials are pervasive. Every time you pop out something that uses a Live ID, an MSA, my marketing is ready to cut my hair if I say Live ID. Oops, I said it again. MSA. Basically, it just works. You don't need to worry about any of those aspects. In Windows 10, we added this same level of integration for Azure Active Directory. You can sign in to your device using an account from your Azure Active Directory. And then we have APIs that allow you to leverage the same capability from your applications. And how does this work? Instead of just adding AD alongside with MSA, we actually created a generic plugin model in which if you are an identity provider, you can just write your plugin. We call those web account providers. And you can add those providers directly at the system level. And then what happens is that those guys have access to what we call system accounts. Those are the accounts that you find when you go in the settings and you search for like your connected accounts to your current user. Those are the accounts that are all in there, which means that you can actually make them available across the board, also to other apps. So you can decrease the number of times in which the user is prompted. And then we have a new API called the Web Account Manager, which is the bridge between those capabilities and your application. So there is this API. It's generic. So you can use the same API signature for talking to any of the supported providers. And this thing will make all the stuff that I described earlier happen. And that's pretty much straightforward. So here, you can imagine that the tokens that you acquire are saved somewhere at the system level. And together with the capability of prompting the user, again, these libraries will have the UX to show. You don't need to worry about creating the UX for gathering the credentials. We also have extra UX for user selection. Let's say that every time you ask for a token, the system will look if there is a system account available. And of course, it will not just give it to your app. The user needs to have a chance of saying, yep, I'm OK with this app to act as myself with this identity. So there is also a selection experience which allows you to do that. It's very neat. The number of APIs that we have in here are a hybrid between the APIs that we had in Windows 8 for MSA and the APIs that we have available in our current Azure Active Directory libraries. How many of you guys ever used the ADAL? Wow, I'm a proud father here. Thank you. Very nice, very nice. OK, so here the pattern is very similar. The idea is that first you start by acquiring a reference to your provider. Given that providers are dynamics, like you can add, like an identity provider might decide to create a plugin. We have an API that allows you to select it. Then you craft what we call a web token request. This is a class which represents the message that we'll be sending. And it has just some standard parameters. And then it has a mechanism for adding provider-specific parameters. So for example, when you're talking to Azure Active Directory, you can talk to many different directories. Like every organization has its own. Whereas when you talk to Microsoft account, there is one big monolithic singleton that you can talk with. So in that case, you don't need this ambiguity between one and the other. So these differences are accounted for by crafting the message in a way that adapts to the specific provider. And then we have a couple of primitives that are these request token async or get token silently async, which sounds very zen and very poetic. And basically, those do the same thing. The only difference is that the second one guarantees that if you are doing an action that cannot show any UX, the system will attempt to get a token without showing anything, and if it fails, it just gives you an error instead of popping something out and ruining your experience. And then all these results come back in this web token request result. You'll see that this model is actually pretty similar to what we have in ADAL. Okay, so I added this slide more for the people that will download it. I know there is a lot of word in it, and you can feel free to ignore it. The message here is, as I said earlier, every time you want to use Azure AD, you need to provision your application in the directory. And in this point in time, in which our bits are still kind of preview quality, you kind of have to do a Patronus token Harry Potter move, in which if you don't say exactly the words of a spell in the correct order, the spell will not work. But hopefully, as we get closer to general availability, the registration operation will be easier. Right now, long story short, you need to extract information about your application, and you need to embed this information in a special kind of URI and use that URI when you register your app, so that when you generate your request, Azure AD can actually send the token back to the correct internal address. Again, I expect these to be much, much simpler afterwards. But I just want to make sure that if you guys want to play with these afterwards and you download the slides, you have exact instructions and you don't have to go through the pain of finding out yourself, as I had to do on my own. OK, so time to switch. Not the Mac yet, but we understand. OK, so my password is, what did you think? Yeah, now I joke about, do I remember it? At least you know that it's pretty long. OK, so what you see in here is a vanilla Windows Universal app. Very simple, very straightforward. And so here I'm already using the token, so let me go a bit higher just to show you how I obtained this token. So as I described earlier, here there is the call that I do for obtaining my provider. First thing I do is I want a web account provider to which I can ask a token for. And the way in which I do so is I specify the base URI that I want to use. Here, if I'd want MSA, I would specify the URL of MSA. Here, instead, I'm specifying the base URL of Azure AD. Then, once I have that, I create a web token request. And here, what I'm passing, pretty simply, is the identifier of my application. It's an identifier that I added to my app, to my Azure AD. And I pass this parameter in which I say, it doesn't matter if you already have this user in the cache, I want my audience to see the pop-out. So I'm actually passing this parameter in which I guarantee that there will be a dialog that comes out. And then I do a couple of things that are AAD specific, which entail taking my properties, like properties of my web request, and add the exact directory I want to talk with. In this case, I'm using this developer tenant on Microsoft.com, which is my test tenant. And then I have, I basically just add the resource that I want to talk with, which is the Graph API. How many of you guys know what is the Graph API? Look at that, pretty much everybody. For everybody else, if you know what LDAP is, imagine this is like the grand child of LDAP. Is LDAP for the cloud and REST and distributed multi-tenant systems. And then at that point, I just make my nice call to request token async, passing this value. And then in these token results, I get back my token. And then later on, I make a call to the graph, which is very simple. I just retrieve my own thumbnail in the system. So let's actually run this guy and hope that the gods of the internet agree with us today. So here we have our little app. As soon as I click that part, the system detects that I have I want a token and pops this thing out. And this is the UI which is being served from Azure AD. So let's see, today I am Mario. And my password is maybe this one. Now, one thing that happens also is that given that my machine is tied to a different organization, the first time I use this user from this other org, I'm being warned that I will be getting, potentially, my provider might ask me to get some policies on my machine in order for them to give me a token. But they didn't happen in this case. But anyway, as you can see, there's Obama-like hope picture of myself in there. So it was very simple and very straightforward. I just got my token, and now next time that I'd ask for this token, I have it in my system, and it's very, very simple. So that's how it works on Windows 10. And of course, the promise is that these will work across all of the devices which run the Windows Universal. I just used the Universal Windows APIs. Very good. I'd say this is probably the only platform that I'm aware of that has directly in the OS this ability of doing OAuth. All the other native apps, native areas, they have kind of like higher level. I'll take your question because I didn't say at the beginning that I was not going to take questions, so my fault. But after this one, I'll wait until the end. Yes, sir?
Another question. Google also has an account manager.
It has an account manager, but the account manager is, sorry, the question is not the only one. Where is the account manager? It's true. On Android, there is the account manager, and we use it. But account manager doesn't really use auth. It uses whatever system you want to use for getting the accounts. Like also, iOS has like the key store. Here, I'm specifically talking about this auth aspect and pluggability of the providers by the protocol. But yes, you are absolutely correct. Very good. OK. So let's say that instead you are doing good old Windows. Instead of targeting only Windows 10, you also wanted to support down level. So you might want to work on the desktop, or you might want to use the Windows Store on 8.1, or you might want to use the Windows Phone 8.1. Now, note that all of these things also work on Windows 10. So if you take one of these apps and you run it on Windows 10, it runs. It will not integrate with the system-level accounts. So you might have a bit of a disconnected experience. But technically, if you already published your app on the store, don't worry. It will work. Or if you have a desktop utility, it will work also on Windows 10. So in order to address those things, we have this library called Active Directory Authentication Library. Now, this is thank you. That isn't really a library. It's more of like a franchise of libraries. Like it's an artifact which we make available across many different platforms, which is designed to help you to do exactly the tasks I described. It helps you to be a client to Azure Active Directory. And it's available across all of these platforms, and more are coming. In fact, if you have feedback on which new platforms you want to see first, please let us know. Python right now is pretty high on the list. Of course, all of these is open source. If you go on your, if you go on GitHub, you go on Azure AD, which is, for once, a pretty easy to remember address. So if you go into this address, you will basically find all of our libraries for all our platforms. And if you feel like you are bored in the weekend and you want to contribute fantastic features, we'd welcome you with open arms. Please do. We really like that. In fact, this is happening all the time. Like a good portion of our JavaScript version of the DLL got community contributions, and they are pretty good. OK. The idea is that we try to give you very consistent primitives, so things that help you to perform the tasks that I described earlier, but we try to be good citizens of the platforms that we are targeting. So earlier I joked about how odd to me it sounds to have to specify the first parameter when you create Objective-C methods. However, regardless of how odd it looks to me, it's the way in which iOS operates, and so we do that. So all our libraries behave as they are supposed to behave on their own platform. But at high level, the way in which you perform the tasks and the concepts that you need to manipulate, they might change name, they might have a different calling pattern, but they are the same, which also helps us to remain sane because we have to manage all these different libraries. And if each of those would behave in a different way, we'd probably commit suicide. It's not a protocol library. Now, you are insiders, and so you know now that we use a lot of auth behind the scenes, but in reality, you should not count on that. Like, we do whatever is necessary to give you a functionality that you want. So there is a scenario in which you pass username and password, and behind the scenes, we figure out if we have to use auth or use WS Trust with a local version of ADFS, get a SAML token, and exchange it for another type of token. All of this happens below the surface, and you don't need to worry about. In the next version, we might completely change what we do. As long as the signature of a method remains the same, you should be fine. And yep, here there's the way in which it works. We tried to put in the object model all the things that you think of when you're thinking about your problem, even if you don't know anything at all about the protocol. So the first thing is, where are the user living? So what is your directory? So we have an object which represents your directory in your code. And that's what we call authentication context. And you create it very easily. You just pass the URL to your directory. Why do we ask for a URL? One little known fact about Azure AD is that there are multiple instances of Azure AD. Like there is one that is like the public cloud in here, but then we have other instances. For example, there is one instance in China, which is completely decoupled from this one. It's like an entirely different instance. So if I want to specify that first part of the address, which by the way I should have updated because it now is loginmicrosoftonline.com, would be that part. The second part instead is your actual organizations. Then what else do I have? I have a resource that I want to call. I have the client that wants to get the token. And of course, I have my users and the tokens that I get back. So the idea is that I have these acquire token async. It's not that we use a different name from Windows 10 because we don't like you and we want to confuse you. It's more of like a matter of timing. This thing came earlier than the stuff that came out for Windows 10. And in this part, we just specify what is the resource that we want. In this case, that would be exchange, and the identifier of a client. And the result is represented by this authentication result. And this has tokens, it has information about the user, and so on and so forth. This syntax is C#, but you can expect iOS to look the same, more or less, Java to look the same, more or less, and so on and so forth. You'll always find an authentication context. You always find an acquired token. You will always find an authentication result. Now, specifically in ADAL.NET, today, the one that is supported is version 2. And in version 2, we have a number of things that are interesting. We have all the same features that you have seen in Windows 10, minus the connection to the operating system, because this has to work also on down platform. And then we have the use of direct Kerberos. So if you are on a domain-joined machine, we'll just take advantage of it. And we allow you to give us directly username and password, which you cannot do instead with a broker. And then in the same package, we also have Windows Runtime components, which target the Windows Store and Windows Store for the phone. Now, if you're familiar with the Windows Runtime components, you know that those are special kind of libraries that you can use from any of the languages that you use on Windows Store apps. So even if we wrote those things in C#, you can use them from Win.js, you can use them from C++. Those are less tested scenarios because the vast majority of people ask us for C#, but technically, if you want to do it, you can do it. The other thing is that those platforms are sandboxed. So we know where to save tokens and keep them secure and isolated from other apps. So that's what we do. Out of the box, we give you a persistent cache. If you open an app, get a token, close this app, next time you open it, the token will still be there, and you'll be able to reuse it. And like for 90 days, your user will be able to use this without being prompted. Whereas on the desktop, we really don't know where you want to save stuff. So by default, we save stuff in memory, but it's very easy for you to change the default cache and use it on a local disk, for example. And here, I'll just give you a very quick demo. Let's see. Let's use this guy. So here, I'm doing pretty much the same stuff that I did earlier. I have one app which retrieves my picture from the directory. And, but this time, I'm doing this in .NET. Maybe within the next couple of hours. OK, so here I have like a classic old-style form. And here I have one pattern which we use very often, which I think it's worth demonstrating, which is I create my authentication context as I described earlier. So I just pass my directory. Then first thing I do is I try to get a token without popping out any UI. So if I have something in my cache, I will get lucky and I will just get back a token. Now, if I don't manage, there is one very specific exception that comes out. Wait, let me come back in. Yes. I have one specific error which says, I tried my best to get this token without popping anything out, but sorry, the patient is dead. Then at that point, we can catch it, and we make the other call, the one in which we know that will pop out the interface. And then in that case, you minimize the pop-ups that the user can have. We also have one flavor in which we do this control yourself, but we have noticed that customers prefer to have these two lines because it's just easier to debug if something goes wrong. Whereas if you just call us and we make the decision, then you have to turn on diagnostic and see in our logs why that happened. So just hit F5. Slowly, slowly. I think I already have a token in my belly, and in fact, here I am. And here, let me just update a better shot. Ta-da! So all very easy and very straightforward. And the code that you have seen here would apply across the board. You can run it on any version of Windows, not just desktop. OK. So of course, one of the questions that I get from my own colleagues is, OK, there are now these new APIs on Windows 10, and you have been boring us with ADAL for the last couple of years. Which one do you want me to use? And the answer is whatever is best for your scenario. If you are targeting Windows Universal Apps on Windows 10, then if you use the Web Account Manager, the APIs we saw earlier, then you have the best, most direct access to the system resources. So I would highly recommend that you use the Web Account Manager. If you need to run your applications also on other versions of Windows, or for Xamarin, if you actually want to reuse the exact same C# code on iOS and Android, then you might want to use ADAL. Also, there are things that we allow with ADAL, mostly for legacy purposes, such as, for example, passing username and password. And you can't do that with a Web Account Manager. So again, if, for example, you needed to do a headless client that runs as a worker role somewhere, then you have to use ADAL. Now, the good news is that hopefully in a short time, we'll eliminate the opportunity cost here. we'll have a version of ADAL that upon waking up, if it realizes that it wakes up on a Windows 10 device, instead of performing its own calls and using its own cache, it will just turn and translate your calls into calls to the web account manager. So at that point, if you use ADAL, you'll have a best of both worlds. But we are not there yet, so very good. OK, so for the native iOS part, how many of you guys are iOS developers? 1, 2, 3, 4, 5, 6, 7. 7, yep, not too bad. How many Android developers? 1, 2, 3, 4. Less. Windows developers? Non-developers? I've seen people that did not move their arms at all. How are you still awake if you're not a developer? Or also, if you're a developer, I'm still surprised that you are. Thank you. So very quickly, we have an Objective-C library, written in Objective-C. It's available through CocoaPods, so again, pretty standard iOS practice. It's being used in many of the products that you see on iOS from Microsoft. So pretty much all the iOS products that you download on your iDevice. And if you see something popping out and asking for your Azure AD credentials, they are using ADAL iOS. It's actually shipping with Office. And it uses specific features, such as the keychain. So if you have more than one app, you can have all those apps share tokens, because apps from the same publisher can use the same portion of the keychain. And given that we use the keychain for saving the tokens, you can actually achieve SSO on the device across all the apps of your suite, which is pretty nice. And for internet scenarios, we also support NTLM. Android, very similar, with the difference that we have like 1,000 different ways of installing it. You can use Maven, you can use Gravel, you can use Git clone, you can take the zip source. Whatever system is a part of your workflow, we try to support it. And we use the Android key store for encrypting your tokens, and we leave them in a shared preference file. And one really interesting feature of our Android library is that it integrates with the account manager and the Azure Authenticator app. So we have this Azure Authenticator app, which makes it easier for you to deal with multi-factor auth. And we actually integrate with that. So if you have it on board, and you have an app that uses tokens from AAD, through that app can broker the caching of the tokens. And so you can achieve SSO across the board, which again is a very nice feature. OK, time to pivot around languages instead of platforms. How many of you guys ever used Xamarin? All right, fantastic. So for everybody else, Xamarin is a fantastic, very neat trick. It's like magic to me, which allows you to use C# to develop applications and then run those applications on iOS and on Android. Of course, also on Windows, but the thing that is like magical is that you can open this thing from a Mac and develop in C#. And they do so because they leverage like runtimes that know how to run intermediate code, intermediate language, which is really nice. And normally, you structure your solution with a project which contains shared code. It's like the bulk of your project, like your business logic. You can share it by creating a portable class library, or you can actually literally share the code and recompile it also when integrated with other projects. And then you have, again, C#, still C#, but platform-specific C# projects, which reference this part, and that they take care of all the aspects that are intrinsically different across platforms, such as UX elements, such as storage, and all the things that are specific to the platform. Now, how do you actually use ADAL for this? Well, we did kind of what I believe is a pretty neat trick. In the preview version of ADAL, which supports all these, we have one NuGet which contains assemblies of different flavors. We have one portable class library which contains all of our surface. So if you want to make calls to our primitives, all you need is that portable class library. And then we have platform-specific libraries which contain UX for hosting the browser, specific technology for saving tokens on a specific area, and anything else which is platform-specific. And then we do dynamic dependency injection. Let's say that the idea is that if you structure your project, just like I said earlier, when you go in Visual Studio and you say add NuGet package, the system knows you are doing a PCL, so it just adds a reference to this specific part. Then say that you want to do your iOS part. Then you create your iOS project, you create all the UX of your app for iOS, and then you add a reference to your own PCL and to ADAL. What happens is that the system clearly also brings the PCL, our ADAL PCL in because it's needed by the reference that you're using, but then also brings the iOS-specific stuff. And the same goes for Android and for any of the flavors of Windows. And the idea is that at the last moment, you just pass a reference to a basically pointer to the window of your app, and ADAL takes that pointer and says, this pointer, yep, looks like Android. And then grabs the classes for showing UX in Android and injects them in the process. So this allows you to achieve the highest level of reuse. So you basically put all of your authentication code in here, and then you just call your high-level library from the platform-specific area, which is very, very neat. I really like it. And time to pull out the Mac. Actually, before pulling out the Mac, let me just show you in Visual Studio how this looks like. This is just for giving you an idea in Visual Studio of how that diagram plays out. Maybe before tomorrow. Come on. If you think this thing is slow, please make a petition for my boss to buy me a more powerful machine. It's actually partly my fault, because I put far too much stuff. But get rid of it from the recording. It's just slow. OK, so now that it loaded everything, here, as you can see here, there is the structure that I described. In this specific sample, we have a very simple app which allows you to search for the directory. So I have a portable class library which implements this functionality and contains all the calls to ADAL. And then I surface a parameter which says, dear platform-specific project, when you call me, pass me this pointer to your main window so that I will know on which platform I am. And then in all of these other platforms, as you can see, Android, desktop, iOS, Windows Phone, Windows Store, in all those, I'm just using that library. I'm just passing the pointer and nothing else. So I'm really like, I no longer worry about identity at all. It's just taken care of in that aspect. But given that it's more spectacular, I'll show you this as it happens on the different device, which is 3 to 1. 3 to 1. Ta-da! Very good. Every time I lose 10 years of life expectancy. Thank you. And to think that I quit smoking specifically for this. OK, what you see in here is exactly the same project, but in Xamarin Studio. Xamarin Studio is a development environment which allows you to open projects straight from Visual Studio that were made with Xamarin templates. Of course, you will not be able to run the Windows stuff in here in the same way which you cannot run the Mac stuff on Windows. But I can run the Mac stuff. And in fact, in here, I'll select this guy and just hit F5. And I'm running exactly the same code that you saw on the other side. And so now this thing will crank out a bit and spit out a apparently too big for this screen application. Here is just rendering the platform-specific part. Let me Save it. I want to search for Mario. And then the thing here pops out the same page that I get back. But as you can see, of course, it's formatted because it knows that it's coming on the Mac. So it's adapting it accordingly. So Mario, developer tenant. And given that this platform does not allow me to write this without you seeing it, I have to do a little blackout here as I write it. I hope I wrote it correctly, otherwise I'll have to do this pantomime again. And ta-da! I managed to get my token, and so basically I'm running C# code directly in iOS exactly with the same library. So very nice, very straightforward. I could show you exactly the same with Android, except that the Android emulator is slow, very slow. So it doesn't work very well for a demo on stage, but you can try this yourself. You can just download the samples. They are very straightforward. OK, so next we want to talk about Cordova. How many of you guys ever used Cordova? How many of you guys know what is Cordova? Look at that. Excellent. For everybody else, Cordova is another very neat trick. The idea is that it provides you with a special frame where you can render HTML5 applications with their own JavaScript, which are actually sitting on your disk. So you're not serving JavaScript from a server. It's just the syntax of the language that you use for writing your native app. And Cordova provides a number of plugins which surface the capability of the platform, so that despite the fact that you are running inside of this frame, you can do things like GPS, you can do things like anything that the device allows. So we created a plugin that allows you to actually take advantage of that. So there is a version of ADAL that works for Cordova. So we have this plugin, which presents a JavaScript facade regardless of the platform you are on. But then, depending on the platform where you install it, you end up actually using one of the native ADALs. So if you are on iOS and you run this thing and you add this plugin will actually bring down also the native ADAL. So when you call it, you are actually using the local version. So all the things that I described earlier that work with native iOS, you can take advantage from JavaScript. And frankly, it's amazing to me because you end up writing very little code and being able to run exactly the same app across multiple environments. So here I have, here I am showing you one of our samples where you just make pretty much the same calls that I was describing earlier with acquire token async. If it doesn't work, acquire token full. And it's all JavaScript. It's exactly the same JavaScript that works across the board. It's just this file. There is this JS file, and there is a little HTML file. That's all my application needs. It's barely 200 lines of code. And it's all based on command line. So I can just say Cordova emulate iOS. And this thing pops out an emulator, loads the Cordova frame. In the Cordova frame, loads the HTML file up that I described, loads the JavaScript behind it, and gets me, my local UX. This is the same functionality that I described for Xamarin, but for this part. And to show you that it's actually using the local part, as you can see, this worked right away because I already had a token cached. Like I used my native ADAL iOS for another app, and so here I already had my token cached. So if JavaScript is your thing, Cordova is pretty much the way to go for doing this stuff. OK, so we did that. So, well, for once, I managed actually not to have to skip any slides. I did all of them, and I still 20 seconds, 19, 18. So as I promised at the beginning, if you want to use Azure Active Directory, you are free to choose to go native all the way, or you can use any of the multi-target platform stacks that are available on the market. And whatever you choose, we have your back. We make it very easy for you to take advantage of it. Thank you. Now, I will take some questions, but not a lot, because unfortunately, somebody in the organization really hates me, and they put another session just afterwards. And so I'll have to do a couple of adjustments. So by all means.
Multi-factor authentication. I have a customer who wants to call using authentication from a web app and a WPF app. And if it calls from WPF, he doesn't want it to be multi-factor authentication. And if you call it from the web app, he does, which I know you can do with AD Premium by signing. Is there any other way to do that? Is there any information in the headers or the claims or anything that tells you it did multi-factor authentication?
So the question is there any chance of adapting the level of authentication depending on the type of client and outside of premium? And I think that at this point in time, not really. We are working on having granular access so that we'll have policies that are based on your device. So rather than WPF versus web, it will be something to the effect of, I'll allow you to do certain things only if you are showing me a token that has been obtained from a trusted device. But I actually cannot tell you if that will require premium or if it will be available to everybody. I can follow up.
All right, thank you.
Thank you. Anybody? Yes, sir. So the question is it possible to plug in a custom multi-authentication factor in the chain in Azure AD? And the answer is it is, as long as you do this on premises. That's to say that Azure AD does not run your own code, but it will loop in your local ADFS if you are projecting your directory from your own premises. The latest supported version of the DFS has extensibility points which allow you to plug in your custom authentication factor. And so at that point, you can leverage that mechanism for shipping your own.
Can you tell me what I look for this one?
I can look it up and give that to you offline. All right. So, yes, sir. The question is it possible to use tokens that I get from AAD to secure my own APIs? And the answer is absolutely yes. In fact, if you go to our samples page, Azure AD samples, and you search for, I need to switch, thank you. And you search for, oops, now you're seeing all the private ones. That wasn't a very good idea, sorry. If you search for Web API, why is it not filtering? Okay. All the ones here that say Web API typically call a custom project that you find in the solution, which is a custom Web API. And it shows you how to use our middleware for protecting your own API, for validating the token that comes in, and extract the identity of a user so that you have it available from your own code in your Web API. In the session in 1 hour and a half, I'm going to touch on that as well. All right. Yes, sir?
How would you deal with a multiple AD scenario in addition with a non-AD on a single client?
So the question is, how would you deal with multiple ADs and non-ADs? when you use a DLL, the assumption is that you will use Active Directory, be it ADFS or Azure AD. That's what we assume. Like, if you want to use the different providers, you have to deal with their own libraries. However, if you are using multiple Azure ADs, then it's very easy. Every time you need to talk to a different AD, you create a different authentication context passing a different authority. So if you are working with Contoso and Fabricam, you create an authentication context passing login, microsoftonline.com/fabricam on microsoft.com, and the other one is against Contoso. And then when you ask token using one context or the other context, you'll get different ones. And you can actually reuse the same token cache so that you don't need to maintain different stores. The token cache will know how to keep those things separated. We do that for you. The follow-up is, do we have to look at the user and see where it goes? We have mechanisms that help you to do that. Like, you can also create a context by passing a special keyword instead of a tenant. Instead of saying Contoso or Fabricam, you say common. And that thing tells the directory that you want the user to decide what is the actual directory at runtime. And once the user types in their user, and if they hit tab, this thing goes to the backend, looks at the corresponding domain, finds out if it's only the cloud or if there is also an ADFS. If there is an ADFS, what is the address, and redirects. So we do all of that. And once you get back the token, we extract from the response the information, and we update your context. So that if you created this context saying common, but then afterwards you inspect it, you'll see that now it will be Contoso. Because once we receive back the token, we know that it's no longer ambiguous. You wanted it to be Contoso. All right. I will take just this one, and then we'll have to run because I think that somebody will need to set this stuff up. Go ahead.
So I know there's the plain-space federations that can actually connect application using Windows Identity Foundation. So in that scenario, talking with the third party or the type of identity. So how you sort of like looking for solutions in that scenario versus this type of like ADL and then the Windows Account Manager? So
the question is on differences between ADAL and traditional Windows Identity Foundation scenarios. So if you have an opportunity to come to the next session, you'll see these more clearly. But the idea is that the Windows Identity Foundation really plays a different role. Windows Identity Foundation was designed to protect resources, whereas in this case, you are on the other side of the equation. Instead of sitting in front of a resource and making sure that only authenticated calls take place, you are the requester, and you are obtaining the token that you need to send in order to satisfy this watchdog. So we no longer use Windows Identity. Well, we still support it, but we now have more modern versions of libraries that perform the same task. The idea here is that when you use ADAL, normally you are not calling a web app, but you are calling a web API. So the protocol that you use is slightly different. Like in a web app case, normally you play with cookies, whereas when you call a web API, you don't really have a context for cookies. You just get tokens and you send them over. So normally you would not protect a web API using Windows Identity Foundation, although it's possible. It's a bit of a chore, but it's possible. You'd instead use these new modern libraries in OWIN and similar. Again, if you have an opportunity, I'm happy to show that afterwards. Great. Very last one. Go ahead. Yes.
You said that with the authentication provider or authorization provider, all the resources that we want to protect need to be registered upfront before we can get the access token for the resource.
Correct.
Is that true?
You have, when you create the entry that describes your application in the directory, you have to declare what are the resources that you will ask access for. And then it's still up to the user to grant or deny consent for getting those resources. But we need that information because when you ask for a token for your custom API, like the gentleman described, you need to be able to say, those are the things that I need to have access to. Or say that I'm getting access to your web API, and your web API in itself needs to have access to Exchange, SharePoint, and similar. You don't want the user to have too many pop-ups. So if you specify all of that stuff in advance, once the AD shows you the consent page, it can aggregate all the things that you need so that the user has just one place in which it says, OK. Perfect. Great. Thanks again. And now I'll just turn everything off.